Now we're going to be finding unknown sides using trigonometric ratios. So what that means is if we have a triangle and we have a degrees here and we have one side, let's say this is 5, and we want to find either our opposite or our adjacent, we can use our trig ratios to find them. That's essentially what we're doing. We're trying to find the lengths of these sides. And we're given one side and an angle. So, let's get into it. If theta is in degrees, the ratio for sine, cos, and tan is accurately found by using a calculator in degrees mode. Okay, so you need to make sure your calculator has this little d in there. Okay, you can look up how to do that. We're just going to keep moving on with the lesson. If the angles and one other side of the right angle triangle are known, then the other side length can be found using sine, cos, and tangent ratios. Okay. Now, I kind of like these examples, but I think the best way to learn is actually by doing them. So I am just going to show you how we're going to do it, and there's a little bit of equations involved. So just to remind you what the equations are, if I have 5x equals 10, if I wanted to find out what x was, what I did to one side of the equation, remember it's like a balancing board, divide this side by 5, divide this side by 5. If I divide both sides by 5, x, that'll be x, and 10 divided by 5 equals 2, because 5 times 2 equals 10. Okay, so we're going to be doing this idea of using equations with trigonometric ratios. So you've got to understand that. Okay, so if we've got, actually I need to go over one quick thing before we do our examples. Now, in counting numbers, usually where you count numbers, we count things in terms of 10, okay, because we have 10 fingers. Okay, that's how we have a base 10. But sometimes we have base 60. Base 60 is in clocks, in time, and it's also in degrees. Okay, so if we're measuring degrees, it goes our degrees, and then it's going to be minutes, and it's going to be seconds. Okay, now it's going to be there are 60 minutes in a degrees, and 60 seconds in a minute. So if we have something like this, for example, 22.5 degrees is 20 degrees and 30 seconds, because half of 60 is 30. And then if we have 50.175, well, that is 50 degrees, 10 minutes, and 30 seconds. Now, what I'm going to do, what I'm going to show you, is in your calculators, you're going to have this button here. Okay, this has degrees, minutes, and seconds. We're not going to worry about seconds too much, but we're just going to be focusing on degrees and minutes. So just putting this in your calculator, making sure that we're familiar with it, it's asking us to put this in degree mode and to evaluate the following to two decimal places. Okay, so if we have sine 50 degrees, that equals 0.766. Okay, so a length could be 0.766 to two decimal places, that is 0.77. We have cos 16, hit our degree button just here. It's going to be 0.96. Tan, 77 degrees, 4.33. If we have tan 15.6 degrees, we're going to have this, 0.28. Finally, if we have sine 22 degrees and 30 minutes, we press it again. Okay, you don't have to close the brackets, but you can if you choose to. Press equals 0.38. Now, the reason why they just want you to do this is they want you to understand that there is 30 minutes in a degrees, 60 minutes in a degrees, and that you need to round sometimes. Okay, but we're not going to worry about that for now. We're just getting calculator skills, making sure where our degrees button is, and now we're going to find unknown sides using equations. So find the value of x in the equation cos 20 degrees equals x over 3 to 2 decimal places. Okay, I might have to do this above because I haven't left myself enough room. Cos 20 degrees equals x over 3. Okay, so to get x by itself, we are going to multiply both sides by 3. Now, it can be a little bit scary because you're only just introduced to these these trig ratios, especially cos, and with degrees. So people get a little bit scared when they see this, but don't worry, just go back to your training with equations. So what this is going to be is 3 cos 20 degrees. If you're stuck and you're a little bit scared, you can still leave the times in there, but remember times glues things together so we can get rid of it. That will leave us with x. Now, if we've got x equals this, we can put this into our calculator. So we can go 3 cos 20 degrees equals, and we find out what x equals to 2 decimal places. So that's going to be 2.82. So 2.8, say 19 ... equals x. Bring it over here. X equals 2.82 to 2 dp. Okay, so we'll just find out what our answer is, which is accurate, and then round it to 2 decimal places. Okay, so let's try and find these unknown sides. For each of the triangles, find the value of x correct to 2 decimal places. Okay, this is the real skill that we're trying to focus on here. These are all preliminary skills. Here we have our angle. Here we have our side, which is also our hypotenuse. And here we have the side opposite our angle, which is our opposite. So, what we need to start with is our SOHCAHTOA. Okay, here we have a hypotenuse and an opposite. That is going to be our S, so it's our sine. So we're going to write sine, our theta, which is 38 degrees, is our opposite over our hypotenuse. So x over 7. Now to get x by itself is going to be using what we learnt with equations. We're going to multiply both sides by 7. That's going to cancel this out. So 7 sine 38 degrees equals x. And then we're just going to put that in our calculator. 7 sine 38 degrees. Okay, we're rounding it to 2 decimal places, so it's going to be 4.31, but let's just do our accurate answer for now. So x equals 4.3096 ... and let's round it to 2 decimal places, which is 4.31 to dp. Excellent. So if we're just kind of like looking back at this, it is very daunting to take all of this in, because you've learnt trig ratios, you've learnt degrees, you've learned how to use trig ratios, how to figure out the triangle. There's a lot of setup in this question, but the actual calculations and the mathematics behind it is actually very easy. Because you just get an equation times both sides by 7, put this in your calculator and you got your answer. But the actual setup and identifying all the angles, using this and making sure it's accurate, that is the hard part. Okay? So please always make sure you write this at the top of the page and use it. Let's do another one. This is our angle. This is our opposite. This is our adjacent. So we're going, okay, O and A, that's our T, so that's our tan. So we need to write tan theta, which is, theta is 42 at this point. Tan 42 degrees equals our opposite over our adjacent. So our x over 4. So from here, we need to get the x by itself, so we're going to multiply both sides by 4. I've left myself enough room there. So it becomes 4, 10, 42 degrees equals x, because these cancel out. I'm going to put this in my calculator. 4, 10, 42 degrees, and then it equals, okay, 2 decimal places, that's going to be 60, but let's do our rough answer first. 3.6016 dot dot dot, x equals 3.60 to 2 dp. You still have to put the 0 there if it asks for 2 decimal places. That is accurate. Do not just write 3.6. And our last one, I'm going to need a new sheet for this. Okay, let's write next to. That should be better. Okay, we have our angle. We have a side next to, which is our adjacent. We have a side just here, which is opposite our right angle, which is our hypotenuse. So looking back at our trig ratio, A and H, that's this one, the C. C stands for cos, so we're using cos. So let's write that out. Cos 24 degrees, which is our angle, and is A over H. So this is x over 10. That's the hard part. Multiply both sides by 10. I'm just going to move this across. This becomes 10 cos 24 degrees equals x. Let's put that into our calculator. 10 cos 24 degrees, 9.15. Okay, that will be 9.14, but let's do our accurate answer to begin with. X equals 9.135 dot 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 dot. X equals 9.14 to 2 dp. You need to have these two lines, okay? These are not the same. This is your accurate answer saying this is what it is, this is what the answer required. So mathematically speaking, this is accurate. Technically, this is what the pre-resgrate, I can't even say that word, of what the question wants. And that's all there is. So the main piece of advice, again, please write this at the top of your page and refer to it. You are just trying to find the missing sides, using your trig ratios. The hard part is setting it up and figuring out what sides and such, and using the correct trig ratio. The most common mistake is people use the incorrect trig ratio and get the wrong answer. So make sure you're just paying attention to this and you're labeling it correctly. That's the most common mistake. And then once you do that, you can just use your equations to get rid of the denominators, and then you'll just put that in your calculator and find out the answer.